Yep, we're recording. Okay, go for it.
Okay, cool. So as you might remember, last week we looked into the part of MuBu which is very much into this field of audio analysis, using different sort of like processing mechanisms. Can you all hear me okay?
Yeah, it's fine.
Okay, cool.
Yeah, I had to go and shut the door.
And today I want to uh, look into possibilities of using drawing and camera to get some data output with that. And this is also all like based on training simple models. I'm wondering, you can also still hear me now, correct?
Yeah,
Yeah,
totally
very good.
fine.
Okay,
Yeah.
cool.
In
Then
fact, you're
we
louder
are.
than you were, so
Okay, well,
I'm turning you
fantastic.
down a little bit.
Oh, I can also turn it down a little bit. Oh
No,
yeah,
no,
I
you're
see.
fine. You're fine. No, this is
Okay.
good. This is good.
No, I turned it down. Otherwise, max MSP could be loud.
Ah, okay.
Okay, cool. Wonderful. Yeah, let's get started on this.
Make sure to share your sound so we hear the Mac stuff too.
Yes,
Oh, you're
actually,
using loopback.
I'm
You're using
again,
loopback. Yeah, I forgot. Yeah,
exactly. I'm
right.
again doing loopback. Okay. So we have a couple of examples here, and I will just go through those and show you what you can do with it. So now again, referencing back actually 2 weeks into the past, this is again one of the objects, so the MLP, the multi-layer perceptron neural network that you can find with the ML star group of objects. And let me just show you what you can do with it. So here, this training gives us a bunch of data, and we can train a network. Everything here is sort of arbitrary. What is interesting is that it's able to match the training and say that basically we have like an output of three weights, and what it gives us is like, let's say, how to say, a likeliness of one of 3 outputs. So now 2 is the most likely output for the data that I'm currently sending. So 0.646 and 0.307. And so I'm showing you this because we will be seeing a bunch of those things in MuBu as well. And I'm sort of trying to say there is quite some overlaps between those different options. And I think it's good to know that there is sort of, let's say, very different versions of the same things in different approaches, which might be handy if you want to investigate into different sort of variants upon the same idea. Yeah, so this is out of the ML star package of objects. Of course, what you could do with it, I'm going to show you that this is also coming back to us later again, is like, let's say I want to play some audio with it. So I'm just taking 3 audio files because we have like 3, let's see. Oh, sorry. But this one doesn't. Okay, never mind. I will show that to you with MuBu. That's also not taking the fun away out of the MuBu part. But what I'm trying to say is you could use this sort of input to, again, control audio input. You could, for example, have like 3 different samples and say, I'm doing the volume mix between 3 different samples. So I play 3 different samples by doing this. And of course, this could again be correlated to, let's say, the input from a camera or something. And that's sort of what we are looking into now. So now comes MuBu. This is a simple hidden Markov model training that I'm doing for different gestures. So I can record gestures by drawing, and then I can output the sort of the rapport between an input and the sort of gestures that I recorded before, which here it's just X and Y. So let me show you how you do that. So I can, for example, now I've given it here a buffer index, number 1, and I'm doing this. And you see it down here, it records my movement. And okay, so that was the maximum amount of time. And now I can say, well, fair enough, I recorded buffer number 1. Okay, let's go to buffer number 2. I click number 2. And you see down here, we are at number 2. So this is buffer number 2 that I'm recording now. I'm doing this. And of course, it's good to have things which are somewhat different. And you see what it measures is position and velocity. Okay, let's go on. Something quite different. Maybe now I'm start repeating myself. You get the idea. So now I can train the model, so the hidden Markov model, onto these 9 different buffers that are recorded. So you see, I can go through those again, and this is the different buffers that I recorded. And of course, it breaks this X and Y values down into velocity and position, so X, Y position, but also speed. You remember that there was one object with ML star that could also do that, which I used in one of the last examples to not only map X, Y values, but also velocity. So again, you see there's quite some overlaps between all those different things, but okay, now I can play. And I can, you see here, this is the likeliest label, what it puts out. So let me play something. And you see now it changes between like 1, 2, 9, 7. So it tries to match the models that it has learned to the data which I'm putting in. Or I can play an example. This is buffer number 1 now, but of course it's also overlapping with 5 and 2. You see, so this is what I recorded as number 1. I'm actually playing buffer number 1. I'm playing buffer number 2. Well, that was clearer. This can easily be matched to 2. I didn't do anything else that was roughly like 2. Let's do 3. 3 is like 3, but 1 was going around so much that it sort of seems to be overlapping with 5 and so forth. Okay, so far so good. This is now just about gesture recognition. I can be doing this by drawing. I could also be doing this by doing other things. Now let's bring in some sound. You see down here, I inserted a lot of samples, and I can play those samples just by the number that is being put out by the hidden Markov model and the likeliest label. So I'm using just now the likeliest label as the number for the sample that is supposed to be playing. So I could be drawing and thus create sound. So let's have a listen how that sounds. Let me know if it's too loud. I'm trying to be gentle. So let's do number 1.
It's not very loud.
Ah,
we can't hear a thing.
Okay. Wait a sec. I need to.
There you go.
Yeah. I need to select the right output device. but it should be working. Let me try this again. To look into MuBu. You hear something now?
Don't hear a thing.
Okay.
Sorry.
Then let me. It's very interesting. 1 sec.
We hear something very quiet, but I think it's coming through your microphone.
Back audio, so that should be all right.
Yeah, it looks like it's okay. Weird.
Perhaps it's being filtered again.
No, this is loopback software. See the Zoom audio device.
Well, actually, maybe you're correct. Let me try this again. Tell me if you hear it. I mean, the noise canceling is just like superior.
Oh, it's a noise canceling. Yeah.
Let's see. Okay, tell me if you hear it. I will go down with the volume.
Yeah.
Man, they really deserve a award for their noise canceling. Okay, let's play some gestures.
Yeah, Nicola, I'm afraid that Zoom does not like your sound. It's canceling them. You're being
It's canceling me. Yeah. See, jumping between the different sounds. Okay, for fun, let's mix this up with some drums. Of course, like last time. Okay, here's the drums. So now what I'm doing with the drums is to, here you see I'm using the marker index to go through different parts of the drum beat, and I'm actually changing the speed of repetition, so period. Let's check this out on itself first. Yeah, some pretty abstract drumming. Okay, let's have a listen how they sound together. Well, you get the idea.
Yeah. Cool.
And I think it's sort of interesting to, you know, the in-between spots where it needs to find an interpretation for something that obviously doesn't fit the learned model. But I think that's something that is quite interesting to achieve, like a different access to material. Like here, I think the kind of drumming that comes out by doing this is quite interesting. Of course, I could be. I mean, now the drawing is sort of very much like a demonstration. I mean, I could be using my Apple Watch again, or I could be using all sorts of sensors to connect this with movement, which is the idea here. And you will see what happens if I use a camera for that.
Nicola, it's interesting. Your gesture number 1, which had like a lot of stuff in it, it kept getting that confused with gesture number 2, which was just like left and right. Because when you were doing number 1, you did a lot of left and right work, you know. So yeah, interesting. There's one of the things I'm going to show about the Wekinator is similar. I think it might also use hidden Markov models, and you'll see the same kinds of stuff.
Yeah, and I think also here it's quite interesting to see the overlaps between those.
Yeah.
Okay, let's do something else. I mean, this is sort of a very basic now, but still, I sort of like it. So what I'm doing is I'm learning some models, the 3 models to be precise, and every time it recognizes a model, for anyone who's light sensitive now, please close your eyes at some point. It's switching the background color. I mean, this is super useless for a stage performance, but it just shows you something. Okay, so here it's the same thing. I give the command here to learn. You see the object's down here, and then it receives here. It's a different kind of model that it's using. It has so many different kinds of gesture following models. I'm not even going through all of those or really presenting the differences so much, but I think it's good just to see a couple of them. I do think that the outcome is somewhat similar. Maybe if you really go into the detail, the different kinds of models of what it's doing between HMM, HAMM, XMM, and so forth might make a difference. I don't know. For my purposes, I think there's quite some alignment as well. But let's have a look. Okay, so learn 1 means I'm learning buffer number 1, and you see down here again, buffer number 1 is being recorded, and I'm doing some circles here. Let's do something else. That's this here. Interesting. And number 3, which is here. Okay. Now I turn it off.
Can I ask that how? What exactly is the model training on? I mean, the scribbles to the sound. How is it mapped in the first place?
Okay. Yeah. Go ahead, Nicola.
I mean, you can see here that it also maps X and Y.
Yeah.
X and Y. It's also mapping velocity, remember.
Oh.
So it's looking at the timing between the things. So both of those are being captured. That's why it's capturing the whole gesture.
Yeah.
If the mapping rule is defined, like, why do we need to train it?
Because it's learning a particular set of velocity and position values is a thing. That's what it's learning to recognize, that thing.
Yeah.
Okay. Then you have another set of velocity and values, which is a different thing. So then it will differentiate between this thing and that thing, depending on what you.
Oh.
Okay.
Yeah, and
well, that's why it's a gesture recognizer. Yeah.
Yeah, and I think at that point it's also there's quite some overlaps with Wekinator at that point, really.
Yeah, they're all very similar. You know, I mean, the Wekinator. I'm just going to show you some much simpler examples. You know, and I think you'll get a sense of it then too, because it's basically the same. It's doing the same thing.
Got it. Thanks.
Yeah. Okay, so now I can draw, and you see I will change the background color. For now, there's actually only 2. That's interesting. I recorded 3. Ah, there was the third. Ha ha ha. Orange is the third.
You got to
Okay.
use the right gesture.
Let's do something more fun now. I'm putting in a camera here, and you see it is measuring the center of the image. I had a different version of this already last time, and you see here's the center, and it measures the XY values. And let's try and see what happens if I do this with the camera. So I have a threshold value here now. Somehow it can I? Ah, yeah, nice. It's very bright here. Let's see.
Oh, there you are.
Can I again use my head? No, it's not. Ah, no. Okay, no, very good. Okay, let's try this. Oh yeah. Oh no, a lot of oneness. Wait, everything is very much like 1 right now. Yep, pretty straight. Okay, let's turn this around a little bit, and I will try and see if I can actually. Oh yeah, okay. Let's try to do this differently, and I'm actually recording data like this. Let's do this.
So now it's recording the gesture from your camera then, right?
Exactly. Did it really work?
Yeah.
Should be working.
Yeah, the center isn't moving that much. I think that's what the trick is.
Yeah, that's a little bit of the. Okay, that's very stable now. Let's try this one.
Yeah.
Well, pretty much 1.
We're going to have to send it to the principal's office. It's not learning very well.
Yeah. But you get the idea.
Yeah.
Well, let's do this again here. Oh, this works.
So essentially, this is.
Yeah, very good.
Gesture recognition.
Yeah. The biggest difference between gesture recognition and then what he's doing earlier is the element of time. And that's included, that's what the velocity is capturing.
Okay.
Okay.
Sound only comes from the parameters.
Right. The sound he's triggering, then the output of this is going to say, I recognize gesture 2 or I recognize gesture 4, and he had that mapped onto the sound that he was playing back. Or now he's got it mapped onto the color of the background. Yeah.
Of the background, yeah. So I'm just so there's this object, you see it down here, BJ color. That's what you can use in Max to change the background color. Yeah. And I just use this select 1, 2, 3. So here's the output of the likeliest model, and I just use select 1, 2, 3 to always send it like a set of 4 different numbers. You see here, first one, red, green, blue, and alpha.
So it recognizes the likeliest?
Yeah, it's trying, when he does a gesture,
yes.
It says, these are all the gestures
trying.
he told me, and it looks like it's this one.
So there's no option like none of the above?
I don't think so. That's a good question. Yeah.
No.
Yeah.
Not really. I mean, I'm certain you could find a way to do this, but it's not.
Yeah.
Not
Actually,
so
I have an
much.
answer to that. Right, I do have an answer to that. When it's none of the above, it just hangs on to its previous gesture. If it doesn't recognize what you're doing, it won't switch to the gesture because it says, I don't know anything. Yeah. That's what it is.
But you can see that here it is, you see one thing is here, but you see that the output is actually more complex. So actually breaking it down to either 1, 2, 3 is somewhat of a simplification. Here's the likelihood for 1, 2, and 3, and 1, 2, and 3.
Oh.
Now 1 goes up. You see, when they surpass each other, that's when the number changes. But it doesn't mean that the likelihood for the other ones isn't there. But I think it's a very good question to say, like, okay, is there a likelihood for something that is not fitting in there?
Right. This is what I noticed when I was working with the Wekinator example, is that it's the differences between its recognition. It's not really good at recognizing gestures, and the differences are not very much, but it's enough to trigger one or the other,
Yeah.
Yeah.
It also depends on the training data.
Yeah, right, exactly, and how good or how noisy that might be, or how many data sets you have, even, Yeah.
Okay, let's do something else. Now we are bringing back the audio. Sorry, can you say that again?
So you're saying all the training always starts from 0.
Yeah.
Yeah, it doesn't have any preset training, right?
Okay.
Yeah, all these always start from 0. I mean, it's really simple. And it's interesting, I think, if you think about like, let's say, the different approaches. But I think definitely you can see a lot of people in music like to work with very small data sets, while people, for example, in literature, like working with very big data sets. So I was at a conference the last weekend that brought together people from music and literature working with AI. It was very interesting for me to see that the literature people like to have like a data set of 175 billion text phrases. Whereas, like, I don't know anyone trying to do this in music. You seem to be working with much smaller data sets where you can really, curate the content, while for them working with GPT-3, they really use a lot of stuff that is not transparent at all. And how do you want to make this transparent? And then the problem is rather, how do you curate such a big data corpus? So it's sort of like approaching the whole thing from different ends.
Actually, Nicola, I do know one example of a huge music data set. And that was done as part of the Google Magenta project, where basically they trained it on actual like samples at the sampling rate. They would play it like a passage from Liszt, doing like some run on the piano. And then you're looking at 44,100 data points per second. And they would analyze it and they would train on this, and then they would turn around and make up weird Liszt sounding music.
Is it instinct?
Yeah, what's that?
Is it instincts? Like the data set, the name of it?
I think so. It was very popular. They publicized this. This is a few years ago, and you click on it and it was like fake Liszt, and it was, And the thing that was impressive though was they were building up the sound waveform from scratch. They didn't have any like synthesizer or anything like that. That's the only example.
But that's a very recent one, is it?
Yeah, it's like in the last year or two, I think. Yeah.
I don't remember seeing that, because I think that's really the interesting, like, sort of next step, is to try to build up waveforms in more or less real time, because that's really the computationally still so expensive.
Oh, they didn't do it in real time. They did not do this in
Okay.
real time. Yeah, and they probably used a pretty powerful computer for it. It was a big demonstration project.
Okay,
Actually, it was more than 2 years ago, because Dan Ellis, I believe, is still alive, because I remember talking to him about it. Interesting.
I have a question. So in the input field, I see that it takes the drawing command. Is it possible to play, say, like a GIF file or a video file where there's some kind of trajectory?
No, you'd have to somehow use a recognizer to know where you were in that. You know, the problem is with the drawing commands, you're generating only 2 data points.
Excellent.
Yeah. And with a video or a GIF file, you have a bunch of them. You have to figure out how to turn that bunch into 2 data points.
Yeah, but that was, I think, that's what I'm trying to show with this centroid object here that I used in this example. That
that's exactly right.
You can break down the video input. I mean, of course, you see my background here. It's very bright. And unfortunately, you see that really I'm not sitting in front of a big Buchla system. Just my fantasy.
Wow.
You see down here, it's really, of course, it's also somewhat of an absurd task, where it's trying to find the middle of an image.
Yeah.
Let's see. In the demonstration file here, actually, you can see this quite well. You see here, this is somewhat easy to understand how this is working, because the comparison of foreground and background sort of works out. So you have this background being quite dark, and then the tennis ball in the hand being quite bright, and then it's easier for it to follow.
Right. Or one of the things that Nicola had done in a different class was you can also track the color, and with that ball being green, it will find the center of that color. But the thing is, it's finding the center, and it's generating then 2 data points out of it.
Yeah. Well, actually, I'm about to bring this one back just now.
Oh, good.
Yeah.
Hey.
Return of the color tracking.
Right.
Let me just. Oh yeah, I find a very good piece of color. Sorry, this is a little bit improvising here right now. One sec. Am I allowed to use this?
Is Viola there?
So I found a very nice, exactly, yes. I found a very nice piece of color here. It's actually a handmade piece to put under cups. Very nice. Okay, so let's play this whole thing again. Now I'm bringing back the audio files and the drums, but this time we're going to play it with a camera. And also here now I basically just add +1 every time I record a buffer, so I do not need to say anymore it's buffer number so and so, but it automatically does this.
Those are pretty insane gestures.
Yeah. Okay, so now we can again train the model, and we say follow, and I could just be doing this, and I could be doing the same thing with the sound that we did before, but I'm not going to do this now. I'm instead going to use the camera and do some color tracking. So usually here you see it tracks my camera, so I have to click open, and then the JIT grab is the object that you use. It's somewhat of the, let's say, if you wanted to think about getting external audio or video in, it's somewhat like the analogon to the ADC, so analog to digital converter object in audio. But this one I actually have to give a metronome, so it requests the input of the camera. In this case, every 30 milliseconds. Okay, and I can do I showed that to you last time. There's actually like a different grid here above that I use to define the color. So I click on it, and actually what it does is defines a color here that it's looking for, and then I get the X, Y values. Okay. And now I should be getting some. Yeah, you can see here, I'm getting some values. Wonderful. And it's not so similar to my glasses that it doesn't work. Perfect. Let's see. Now we need to do this. That should be working, I guess. Yeah. Okay. Now you see I'm getting an output here. It all stays number 8. Why does it all say number 8? Yeah, I know why. Now we should be, yes. Okay, now we should be getting different kinds of sort of stays with number 8. I think what I did in number 8 was sort of a very short gesture.
Yeah, that was the one that was just a little tiny squiggle. So
Yep.
thinking everything is a tiny squiggle. Yeah.
Maybe I would need to do more tiny squiggles. Let's try this. Oh, I need to clear them. Okay, let's do this.
Okay.
Let's try that. Yeah, that works better, but now it's sort of all number 3.
You're just not a very good gesture.
Yeah, maybe this is somewhat medium functionality.
Huh.
Well, let's see, but can we? Yeah, really stays with number 3 quite a bit. Well, anyways, I don't know how far that brings us here with our music demonstration. Maybe somewhere. Still does something. Let's try the other input. Okay, well, I guess you get the idea. I don't want to waste too much time with it, but funny, now it's doing a bunch of different things. Okay, it's somewhat reliable. I guess for performance I should be working on it, but luckily it is only a demonstration.
I wonder when you record the gesture, is it randomly selecting the sample that it's supposed to play?
No, it's again the idea to say that the number of the buffer, which is the likeliest fitting to the input, is the number of the sample that is being played.
Yeah, but initially it was just mapped. Like the gesture 1 should be mapped to sample 1.
Yeah, right.
And you can't exceed, if you just have 10 samples, you can't record 11 gestures.
No.
No, you just have to have more samples, or you can make it more fluid. I mean, with for example, if I put this in the MuBu container, I could also use the onseg object and say, please divide this into the same amount of parts that I have buffers. So if you have 11 buffers, you divide it into 11 parts, for example. I mean, there would be many ways to achieve a more liquid order. I mean, this is somewhat restrictive. But put together there.
The other thing you couldn't see is that he was defining the gestures by mouse click down, start of gesture, and then mouse click up, end of gesture. And the last example, it was sequentially going ahead to the next buffer after each one. So, yeah.
Okay, let's try another one. So this is using different audio buffers to, and then I can learn a gesture that is associated with the audio buffer and draw it directly. I mean, it's somewhat similar to what we did before. Okay, now. I think my number one was a little bit too undefined. Let's do this again.
Yeah.
Everything is number
You're just
one.
not a very good teacher
defined.
here, Nicola.
Yeah.
I think it's like graduate students that's going on strike.
Let's try this. I mean, that should be sort of clear. Or not. Ah. Okay, now since this becomes a little repetitive, let's do the same thing with video. I can do this and actually record video of myself, and I make a video sample. And then I make another video sample. Let's see if we see if my performance was too bad. But now it's jumping between those two videos, and you see that here it's sort of trying to see which model is the more likely. And it sort of becomes an interesting way of resampling video.
Huh.
So but what you see is here the video itself. So here video 1, video 2. The video itself is recorded, but into a JIT matrix set, not into the MuBu buffer. So unfortunately, I mean, I think that would be great, and that's certainly something that I'm very interested to see more about with Flucoma. Unfortunately, the MuBu buffer cannot record video, but I think Flucoma can. So, you know, there's a bunch of overlaps between MuBu and Flucoma as well, but one can do things and the other can do other things. It's interesting to see those different approaches, somewhere overlapping and somewhere they don't. So MuBu doesn't have a video record function, but you can definitely use it to control video. How are we doing on time? I mean, Brad, how much, how long should I still go for? I have a few more examples I want to show.
Yeah, maybe about another 10 or 15 minutes. Does that give you enough?
Yeah, absolutely.
Yeah. Yeah, maybe about 5 minutes on each one. That should do it.
Yeah, yeah. Okay. Let's look at this one here. That's also sort of fun. What it does is to again create a model, and we can use this model to control a resonator that then modifies the audio input. So let's try this. We have audio, we turn on the recognition here, and we have 3 models. So these are actually pre-trained, and now we can turn on the synthesis. And let's have a listen to this, possibly. It's sort of quiet. Can you hear it?
Yeah.
Can you hear my voice?
Yeah.
Yeah. So there's 3 different resonator models. And my voice is running through those. So.
It's hard to talk, isn't it, when you have a delay? Yeah.
Yeah. It becomes very robotic. Yeah, as a Düsseldorfer, I feel reminded of Kraftwerk, of course. So the interesting thing here is that it has 3 different models, and it uses the MFCC analysis of the incoming audio stream as analysis tool to determine the buffer, or to determine the resonator model, which is sort of fun. Okay, now I can record my voice and actually use the recording of the voice as resonator model. So let me just keep on talking, and now maybe I stop, and now I can train the model, and you see I can use, it sounds quite different. Okay, let's do another one. Hello, hello, hello. Okay. Now I can actually use my voice as a resonator, and it's sort of an interesting feedback logic of training a model. Okay. And also the idea of sort of the voice becoming a model for a resonator is sort of interesting in this. Okay, another one. Use another voice sample. Okay, now train again. And you see now it's all like voice. I don't know if it sounds so different, but the idea is there.
Yeah. It's
Okay.
picking up the pitches in your voice more, I can tell.
Yeah. Okay. Well, now this one is going to be fun. I'm now training the audio input to certain labels, so I'm labeling the audios. So this is the first point where maybe we can talk about somewhat like supervised learning. I don't know, but really the idea is to label the inputs retrospectively, and then I'm going to control a video filters with it. So let's have a look. I will just record a few vowels here. E, I, O, U, Seal. Okay, now I put the labels, do the training, and now I play. E, I. That's out. Okay, sorry. I think I did something wrong. Wait, let me do this again. If it works, it's interesting. One sec. Okay, again. So I have my voice here coming in. Let's do this. But somehow the different buffers don't work.
Do you have to hit the add buffer
Oh.
next to it?
Nah, that doesn't really work.
Huh.
It was working. I wonder what the problem is. Very sorry for that. Because the outcome is sort of nice. Let me try this again. E, I, O, U, Seal. Let's see. At least we get the idea. So now what I'm doing is using a bunch of different video filters here, and I'm actually turning on here, camera again. Okay. And now you see the image here, And actually, we can go full screen on that. Where is it? Oh, yeah, here. Sorry. Okay, like this. Now you see the image. And now let's do this. And now I can speak and change the video filter by that. That's at least the idea. Oh yeah. It's somewhat flaky right now, but the idea would really be here to, and it sort of worked better in terms of being precise about the recognition. Still have to investigate what's the problem, but I mean, I think it is interesting to change the video to be able to ideally have a precise control about the video filter just by a specific sound.
Nicola, you look like you're from the 1970s.
Yeah, totally. Seal. Oh, okay. Well.
Oh, wow.
I mean, it's some very basic video filters, but I think it's sort of fun to control the video filters like this. Okay. Oh. Yeah, interesting. Of course, now I'm not repeating the input much, but you see it's sort of building the different sort of likelihoods for those. And that controls the video filters. But E doesn't really work. Oh. Well, sort of, something like this. Anyways, so much for the video filter. But, naja. What's this? Yeah. Of course, we can also turn this whole thing around and record sound and drawing at the same time. So I can speak like this and draw and use this directly for resynthesizing. Sort of. Oh, I need to train. Yeah. Oh, yeah. Now I'm really synthesizing it directly. Speak, like yeah, so I think I mean, of course, here again it's sort of using the same idea. Here's the buffer index that is used for the granular synthesis, and the buffer index is the output from the KNN MFCC combination that is bound also to the drawing. And you see here it actually records sound and XY as well as the velocity of the drawing. So you can do this at the same time into one buffer. Well, anyways, I think that sort of concludes what I had to share. Okay. And now I'm really excited to see how that lines up with Wekinator.
Yeah, I am too. Yeah, this is going to be rather entertaining because I usually kind of work these all up and I actually go through the class, you know. I haven't had time to do that, so this is going to be kind of like on the fly, and I hope it works. Let me share my screen, and I got to make sure I share audio too. Okay, hold on a minute. Share sound. Stereo. Share sound. Stereo. Okay, let me share. All right, and let me get rid of some of this stuff. We don't need this one. Uh-oh, yes we do. I just made everybody disappear. Sorry about that. What happens if I shut this off? There. Let me get this out of the way too. There. Okay, and we don't need this. We don't need those. And this thing is going to be in the way, isn't it? Here. Okay. First of all, I want to show you, I'm going to actually resort to showing you one of Rebecca Febrink, who wrote this. She did a really short little video on how this works. First of all, you should know that the icon for this is this weird bird. That's actually the Wekinator bird, I think, from New Zealand or something like that, okay? So the Wekinator, all these people name their things weird, like MuBu and Flukoma and Wekinator. I guess it's a new field. Okay, but I'm going to show you this quick walkthrough. Okay, it's only about 2 minutes long, and then we're going to kind of duplicate that, but we're going to do it with our own data. Okay, so let me see. I'm going to watch it on YouTube so we can see it bigger. Okay, and it's only about 2 minutes long, like I said. And I'm going to point out some specific things. Oh, shoot.
Palantir's software was developed for the world's most complex environment, for situations where the only certainty is uncertainty. Team software is now equipping corporate organizations with the capability they need to survive and thrive. For times when you need to execute a pivotal transition, for when being the first and the fastest matters, for when you must achieve...
Stop. Okay, here we go. Sorry about that. Okay, this is it. Walk through instructions, okay?
Hi, in this video I'm going to try to show you as quickly as possible how to get started with Wekinator. So here I'm on the Wekinator walkthrough page. You can get here from instructions. And I've downloaded the on-screen mouse control as my input, and I've downloaded this continuous control of sound synthesis as my output. And now I've got both of these running. I've got this input here. I can drag this around the screen, and we're going to use this to control sound. I open up Wekinator, and I need to tell it to listen for 2 inputs, just like you see here on screen. So I'll tell it 2 inputs, and likewise I need to tell it how many things to control. And if you take a look at this output program, you'll see that it tells you it's controlling 3 continuous values. So let's put a 3 here, keep this at continuous, keep everything else at the default settings, and let's go. And now at this point I'll unmute my computer, and you can hear that synthesis going in the background. And I'm going to randomize my synthesis parameters. And I'm going to do this until I find a sound that I like. If I like this sound, I'll put my square and I'll say, I want this sound to happen when my square is there. And I just record a few examples. Here I've recorded 15 examples. Let's find a different sound. Maybe I like this sound. I'm going to put that there. Let's record a few more examples, and let's do this maybe one more time. That one's pretty cool. I like that there. Okay, now I'm going to mute this and train it. And as soon as these things turn green, that says, yep, you're all trained, you're ready to go. And when I hit run, all the XY position from this box is going to be sent continually to Wekinator, and Wekinator is going to use that box position to figure out how to control these 3 sound synthesis sliders. So let's do it.
That's it. Okay. Now, a couple of things about this that's kind of important to realize is, first of all, notice that she's just using this. I'm going to show you the gesture version of it here. There is a gesture thing, but she's using it just to record discrete values. And it's learning what those discrete values would be mapped onto, okay? And what that is a fairly powerful mechanism for doing, say, a data reduction in a data stream. You know, if you're looking for particular features, you can define what those features are, and then have to just put out one value for maybe like 16 different values that form the features. Okay. In fact, that's what we're going to do when I show you my little project. But the other thing to realize is that she's doing it backwards from everything that Nicola did, where basically she defines the output first, and then she goes back and defines the input, and then trains it on that particular input. Okay, so you have to kind of think backwards. That took me a little bit of doing before I realized that, okay? So here's what I'm going to do. We're going to use a very simple synthesis thing called the AM instrument. And how are we doing on time? I don't think I want to go through like working this up, so I'm just going to start the patch up. Okay, so here it comes. Yeah, it's starting over here. My computer isn't as fast as Nicola's, so it takes a while to get these. There we go. All right. I'm going to put this guy up here so you can see that eventually. Okay. So this is basically a very simple sort of thing. I'm not sure why that got turned off. Okay. AM instrument is basically like the FM instrument. You give it a carrier frequency and a modulator frequency. Those are the two inputs to determine the sound. Like I said, it only has two inputs. Okay. And this is going to be our ultimate output. So our output will have two inputs. But it's not as complicated as FM. It only produces a split two sidebands, okay? And let me show you what that sounds like, okay? And notice what I've done is I've made a connection here with those two inlets that are the carrier frequency, modulation frequency. And then this is just like, you know, the panning, and this is how much of each one are we kind of mixing into the amplitude modulation signal. So I'm using half of each one, okay? So let me go here, and let me go up here and make sure my Max is talking properly to the Zoom audio thing. No, it's not. Okay. Zoom audio device. Okay, let me turn this down a little bit because it might be kind of loud. Okay. And let me turn this on. Okay, there it is. Okay. So as I switch this now, that changes one sideband. So you can get like these different sort of things based on the two different inputs. Okay? So that's going to be my ultimate sonifying output. All right? What am I going to use as input? Well, I'm going to return us to our happy years of the JFK weather patch. Oh, wait a minute. Okay. Let me bring it up and we'll kind of review what this data set looked like, okay? And let's see. All right, so this was the data set that I downloaded, and it was from the weather conditions recorded from January through February at JFK International Weather Station, okay? And we looked at the temperature max and the temperature minimum the last time that we were kind of doing some sonifying. Okay, but I'm going to pretend like I want to identify a combination of three different factors. Okay, one's going to be the rainfall amount. That's the precipitation. The other is going to be the wind speed, which I think is this guy here. Okay, I think SNWD is like wind, but I don't know about that for sure. Okay, let's pretend that it is. Okay. Well, actually, no, I'm not looking at wind speed. I'm only looking at three. I'm looking at precipitation, and then I'm going to look at the, no, shoot. Yeah, I'm losing it already, guys. Okay. Ah, yeah, that's what I'm looking at. Okay. This is the wind speed over here. I was thinking SNWD is not wind. Okay. This is the average wind speed. We're going to look at that as one of our sort of points that we're going to try and like identify. Then we're going to look at that. We're going to look at the precipitation associated with that particular wind speed, and we're going to look at the average temperature. Okay, so we're going to look at those three values as defining a feature that we want to sonify. Okay. So let me get that happening here, and this is where it gets a little bit sort of interesting. Okay. And notice that I have this markobj.js. That's Mark Santalucido's object that allows me to walk through the data set. The spreadsheet, okay? And also, oh, Nicola, you need to mute yourself. Something happened there. Or was that me? I don't know. This is a very large sound. Okay.
Yeah.
Yeah, probably. I do all kinds of weird things like that. Okay. Notice also that we had to do some things. I took out the commas that were in there, and I also had to put in little X's in these things that had no values, because otherwise it would generate a zero value and throw off some of our calculations, okay? But we did all that, and let's look at, I think this is the one, I was going to build these by hand to show you, but I think it's easier just to walk you through them, okay? Yeah, okay. So this is the thing. Now, the Wekinator communicates using OSC. And we're familiar with that because that's how we communicated with the processing stuff and things like that, okay? And let me start up the Wekinator so you can see what some of these values are, okay? So there it is. And here it comes, okay? So it's listening for inputs on port 6448, okay? And it's sending outputs on port 12,000, okay? So we're receiving stuff here. Remember, I said that we're going to do this in reverse order, okay? What we're going to do is we're going to define the sound that we want for a particular set of combinations. Then we're going to go to our sort of other patch that looks at those combinations, and we're going to then train it with that particular set of values, okay? So in essence, we're going to be going here, and we're going to be doing what she did. See? All right. Okay, that's a cool sound. Okay. What's that going to represent? Then we go over to our input patcher, and we set it up for the input values that we want. Okay. So let's go ahead and start doing that. First of all, I know that this is going to have three inputs: wind speed, precipitation, and average temperature, okay? And here's where the data reduction comes in place. Contrary to what she did in her video, we're only going to have it produce two outputs. And you can use any combination. I could have 16 inputs and produce two outputs if I wanted, okay? So this is the thing that does the feature recognition. It's important for it, okay? And then everything else is going to be the same, local host. You know, we're doing these continuous things. We're going to look at that later a bit more, okay? But let me go ahead to next, and this brings up this Wekinator screen, okay? All right. And there's our two outputs, okay? And watch what happens when I move this output. Notice that it's setting this value here. Now also notice that I'm multiplying it by 1,000, okay? That's because this goes from 0 to 1. And I want this to be frequencies. This is like what we used to do back in the olden days with the logistic math equations, stuff like that. You just multiply it up so you get 0 to 1,000 hertz, and that's not bad. Now notice this one I'm only multiplying by 100. That's because I found out that you get the best deviation in terms of sound within a range of about 100 from your carrier frequency. That was just fooling around with it. So this will go from 0 to 1, and it'll go from 0 to 100 over here, okay? So we can actually listen to those, you know. You hear that? I really like that as a sound, right? So that sound is going to represent some combination of factors. How do we get the combination of factors? Well, we go to here. You bring up this patch. And this should be familiar to you guys, okay? This is the Markov look at the Excel spreadsheet, okay? And like I said, we're going to be looking at the wind speed, the precipitation, and the rainfall. And the temperature, average temperature, okay? And I noted that column number 4 is the wind speed, so count over 1, 2, 3, 4. There it is. Column number 6 is the precipitation, so there's column number 6, and column number 9 is the temperature. So that's where we're getting the three values that are going to then be sent into our Wekinator to produce the two output values that we select. And so I take those three values, I pack them up, and I say, these are your inputs, Wekinator, and I send it to that 6448, okay? Now, the other thing that I can do is also find the bounds, okay? And now notice there's something, I discovered a bug in my code, believe it or not, okay? And it has to do with how you count. Mark counted these things as 1, 2, 3, 4, 5. I use the C counting, 0, 1, 2, 3, okay? So notice my fine bounds for column number 4 are actually fine bounds for 3, okay? And we're going to just go ahead and do that because that's going to be how we're going to define our boundaries for this thing. So we'll say fine bounds 3, the low is 4.03, the high is 25. Oh, that's a lot of wind, okay? Fine bounds 5, low is 0 rainfall. The other is like an inch, 1.2 inches is a lot, okay? And then this is the temperature, low 17, high 53, okay? All right, so we got this sound, okay? All right, let's say we want that sound to represent when it is at the low of all 3 of these, okay? So what we do is we go over here and we set this one to be the low is 4.03. Okay, this one we set the low is going to be 0. And this one we set the low is going to be 17. Okay? Now we're ready to send those values to the Wekinator so that when they see those values, they will produce that sound. Okay? Now, her little mousy thing was sending the values continuously. Notice when I say start recording, nothing happens. I actually have to send those over by hand and get my different sort of things. So I just recorded 15 values, 14 values for that, okay? So let's now find another sound, okay? Oh, that's a nice sound. Let's make that one represent the high values, okay? So we got the sound set here, okay? Oh, you know what? I need to do it over here. Yeah, hold on. Oh, that's a nice sound. Okay. We use that one for our high values. Notice I had to do it on the Wekinator because the Wekinator doesn't know what those are. So if I trained it, it would like produce the same stuff that I had earlier, okay? So let's put in those 25.5, 1.22, and 53. So this is 25.5, 1.22, and 53, okay? So now I need to train it. So I'm going to start recording, and then I send over a bunch more of these. Let's do about 30 of them, okay? And then let's just do one more point for fun, okay? Like in the middle of these, okay? Or, now let's do one where it's going to be low for wind speed, high for rainfall, and low for temperature, okay? So let's set this up so that the wind speed will be 4.03. The temperature will be 1.22, and the temperature will be 17. The rainfall will be 1.22, okay? So there we've got low, high, low. Let's find a sound to represent that. Okay, that's good because it's different than. So let's now send those values over. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. I'm going to stop recording now. Okay, so now we've got all those things put in. We're going to train it, okay? And I believe you can read about this. This is using a neural network, a basic neural network to recognize those values. So we hit train, boom, and look, it identified those 2 things. Now here's the fun part, okay? We go back over to this. This is already hooked up to send the values over to the Wekinator. All I have to do is hit bang, and it's going to walk through the data, right? So turn this on. I hit bang. Oh, I forgot. I have to turn the Wekinator on. Now. Okay, I probably should have these sounds a bit more different from each other. But basically, you're getting the sense. You know, we can take those 3 values and hear how they're changing simultaneously over time. You know, and like I said, you can choose many more values to recognize much stronger features if you want to, and you know, come up with a whole metric. I spent no time at all thinking about how these sounds would accurately represent what I was trying to do. You know, but I think with this, you could turn it into a pretty powerful tool for you know, doing this kind of feature extraction and all that fun stuff. Okay. All right. Now, that's one way to use the Wekinator. Now I'm going to show you the way to use it that is more like what Nicola had been showing you with the MuBu. Okay. So I'm going to turn this down. I think. What did I do here? Okay. I don't think I actually made sound with this. Okay. Okay. Let's see what we do here. Yeah, this didn't have sound associated with it, okay? Now, a couple of things that I'm introducing here. You can, I'm gonna stop this guy. Yes, and start it up again, okay? And we're gonna go to the basic screen. You can control the Wekinator by sending it OSC messages. So you don't necessarily have to hit the buttons over here. And this is going to be important for this particular little application that I did because of, well, you'll see it, okay? And here's how you do it. You say Wekinator/control/start DTW recording 1, or start DTW recording 2. DTW stands for dynamic time warp. And basically that means it's going to include things like velocity. It's going to do what Nicola was doing with hers, okay? And then I can actually turn the Wekinator on and off over here if I don't want to go out and hit the on and off button, okay? Now, here's why this is important. Okay, I do need, where is it? Yes. I think this is it. No, that's not it. Okay. Is this it? No, that's not it. Oh, it's this one. Yeah, okay. All right. No, it's not it. Uh-oh. I'm missing a max match. Okay. Let me go up here. Sorry, guys. I knew something bad would happen when I wasn't completely. No, that's not it. Oh, no, it's already there. Oh, stupid me. I didn't make it a separate patch. It's this stuff, okay? What this does is this reports to me, like, you know, what Nicola was doing, what Rebecca was doing, my mouse position in X and Y coordinates, okay? And I had to turn it on with this toll thing, you notice, okay? And I'm sending those two inputs over into the Wekinator, okay, with that UDP send, all right? What I'm going to do is do what Nicola did. I'm going to use this to record my mouse gestures. Now, here's the problem. The Wekinator is really set up to record gestures from some sort of external thing, because her instructions for recording a gesture is to hit the plus key and hold it down while you then do the gesture with whatever device you're doing. Well, it's hard to hit the plus key and hold it down when you're trying to use the mouse at the same time to make your gesture. So that's why I included these guys. And basically all my gestures are going to start and stop from there, okay? So let's go ahead and try it out and you'll see how it works, okay? So let me get the Wekinator going. And everything, the number of inputs that I'm going to have are 2, the X and the Y coordinates, okay? The number of outputs, now that's not even going to be a factor because we're going to change this from being continuous to being the dynamic time warping. And notice that it only has one output. This is basically going to do what MuBu was doing. It's going to try to recognize the gesture. And if it says, well, it's gesture number 1 that you taught me, I will print /output 1. Or gesture number 2, I'll print /output 2. So again, I didn't connect this to any sound producing process, but I do want to show you something that's really intriguing about this. But we're going to see it's going to say gesture 1 or gesture 2 up here in the max window, all right? So let's go ahead and get it, it's all set here. So now we go to next, okay? And now, notice that this is now a different sort of thing, okay? And this is where you would hold down the plus key while you did your gesture with your camera or something like this, and then let it up and hit, you know, yeah, whatever. And it's then going to, when you run it, it will try to match those gestures just like MuBu was doing. And it will tell me the degree of match, and you can set a match threshold then down here that will choose between one of the two. So let's go ahead and start doing it, okay? So like I said, I'm going to start recording here. I'll do my gesture and then come out here to stop recording. So I'm going to do two really simple gestures, okay? Gesture number one is I'm just going to go right and then left and turn it off, okay? Let's do it. Right and left. Right and left. I'm giving it several examples. Right and left. Right and left. Right and left. Okay? Now we can actually check it to see if it actually recognizes that gesture now. We can actually start it running here, or I can go up here and click run up here, okay? We can try it, okay? Let's go, oh look, right and then left. Right and then left. Right and then left. Right and left. Up and down, doesn't do it so much, okay? Well, you can see it's pretty flaky, just like the MuBu stuff, okay? Let's record the second gesture now, okay? Up and down. Up and down, up and down, up and down, up and down. Okay, now, let's go over here, and I want to be able to see the max factor. Okay, oh, no wonder it wasn't recognized. The max threshold was set way too high. I need to set it down so this would trigger. That's why it wasn't actually showing me anything, okay? So I'm going to run it, okay? And then we'll go right and left. Oh, right and left. There it goes. There's gesture one, right and left. This is gesture two when I move my mouse. Okay, let's try doing gesture two. Up and down, up and down, up and down. It recognizes gesture two pretty well. Okay, let's go right and left, right and left, right and left, right and left. I'm going to have to set my threshold lower. Okay, let's try this. Right and left. There's the one. Right and left, right and left. Well, I'm going to have to train it some more. Right and left. There it goes. Right and left. There it goes. Look at that. Oh, I'm getting really good at gesture one. Look at that. Gesture one, gesture one, gesture one. Now gesture two. Oh, yeah, gesture two. Oh, yeah. Okay. So basically, that's how this thing works. Okay. Now, there's something really intriguing about this data, though. Okay. That I want to show you. And I'll be honest, I couldn't think of a good way to use it, but I'm sure there probably is. Okay. We can actually go here, and I think, oh, look at all those other things down here. How do you have all those? I don't know. Look, by clicking on that, you can analyze, look at the actual data that it recorded for input one and input two. Remember, input two is the y value, input one is the x value. But here's what's interesting to me. These are comma-separated values. Basically, this is the same format that the data from the Excel spreadsheet is storing its data in. So there's the possibility of being able to use data from, say, the JFK weather or the squirrel census data or something like that to define a gesture. And then you can actually automate the playback through via data set, and Wekinator hopefully might be able to recognize particular gestures. So if you're looking for trends, like you're looking for a rise and a fall in the number of squirrels that are, frolicking in the afternoon, you might be able to somehow bring that data into this and then use the Wekinator to recognize that particular, quote, gesture. Again, I did not try this, but I was just intrigued when I looked at the data, and I said, well, it is quantum-separated values, and that's kind of the general data format for a lot of this stuff. So, yeah, I think there's probably an interesting possibility there. But like I said, I didn't have time to look it up myself. But you can, like I said, you can use it on the data and do some powerful kind of data reduction feature extraction with it, which I think is kind of interesting too. Okay. All right, gang. Well, let me stop my share now. Yeah, we actually wound up a little bit ahead of time, Nicola. So, yay. Yeah, that's the Wekinator. You can tell the Wekinator is a much simpler system because it's really doing only one thing, and it's not trying to do the kind of acoustic analysis and a summation of information retrieval coefficients that the other programs are doing. But it is, in its simplicity, it's kind of powerful, and that you're able to do it. And it really is set up not for this kind of data analysis, but real-time gesture recognition, because that's what the name of the game is for a lot of these guys. In fact, that's what MuBu is excelling at, ML Star too. And we'll see about next time, we'll hear about Fukama. And apparently that's actually a very understandable and very powerful thing. Yeah, Nicola.
There was one thing I still wanted to bring up about Wekinator, and that's that a lot of people like using it together with a camera. Yeah. Can I show a video of Rebecca Feebring sort of demonstrating that with a really like scaled down video?
Yeah, we got about 10 minutes left. Go for it. Yeah, go ahead and share your screen and show it to us.
Let me do this. Just I need to turn down my loopback because otherwise.
Yeah. There's a bunch of video examples on her webpage, including the famous Snakinator that I told you about last time, where it's recognizing snake configuration. Yeah, that's fun. And again, it's from camera, like Nicola said.
Yeah, so here the idea is to use a really, really low-res video to control the drum machine.
Hi, in this quick video, I'm going to show you how to use a really horrible, very simple webcam input program to control a drum machine using webcam.
Oh, that's her.
This is the simple webcam example. I've got a 10 by 10 grid here. I've just downsampled the image coming into my webcam. And so I'm going to tell Wekinator to listen for 100 inputs. And for sound, I've got a little drum machine written in Chuck. And I'm just going to control one drum sound, and I'm going to control it using a classifier. So I'll tell it which of 4 sets of drums to play. So once I put a 100, 1, and 4 here, and I've chosen classifiers here, I'm ready to go. And I can give it some examples. So now I'm going to start by telling Wekinator that when I am here, you can kind of see me down here. When I'm sitting in front of the webcam, I want to play sound 1. So there's a few examples. And now when I move away, I want it to play sound 2. So now you see here I've got 30 examples recorded. I'm going to train my classifier, and now I'm going to run it. And as I move, you see that it changes from 1 to 2. And if I unmute my computer, you'll hear that as a change in the sound. All right, so it's not perfect. It's having some mistakes around here, so I can give it some more examples. And I'm going to start recording and just show it a little bit of variation in my movement in front of the camera. Retrain it and rerun it. And there we go, that's pretty good. I can give it another class. I can say this is my hand in front of the camera. Record some examples. Retrain, this just adds those examples to my existing training data. And now if I run it, it sort of works. It's not super robust, and again, I can add some more examples. Let me do that. Retrain it again and rerun it. And I'm pretty happy with that. If I wanted to save this project, I could save my project somewhere on my computer, give it a name, drum machine, controller 1, and I could reload it later. Everything's going to be trained and ready for me to use.
Cool. Yeah, I'm glad you showed that, because that was one of the ones I didn't show you. That was the classifier thing. So it's kind of like a superset of the basic continuous controller thing, where it's, instead of just producing an output based on who you are in the data set, it's producing discrete sort of things as the output. So it's kind of like halfway there and halfway to the gesture recognizer, although it doesn't have any time component. It doesn't recognize a gesture, it just recognizes a particular configuration. Yeah. Yeah, there's a bunch of cool examples on the Wekinator.org page. So yeah, we'll get that put up and give us some info. Okay. Well, Nicola, you're probably tired now. So
certainly.
okay. Any other questions? Anybody from the from the Zoomers or anything like that? Everybody cool with this? Eliana, we really hope you feel better soon and you don't have to go to the what you call it, isolation chamber.
Thank you. I'm in the isolation chamber,
Oh, we want to get you out of there then.
but I feel
Okay.
like I'm gonna be okay.
Okay.
I don't feel too bad.
Okay, I'm going to stop recording here.